Okay, this next application of integrating exponentials requires slightly a more complex approach because what we have here are actually two separate areas. One bound by the curve y equals e to the x from -1 up to x equals 0 or the y-axis. And then we have this other area here between x equals 0 and x equals 1 under the curve y equals e to the negative x. Hopefully we can see that these two areas here are in fact identical areas. So we could set this up one of two ways. We could set it up as a equals the integral from -1 to 0 under this curve here, e to the x dx, and we could actually double that area, or we could set it up to find this area here and double it. So the area would be 2 times the integral from 0 to 1 under this curve, which is e to the negative x. And we'll do that with respect to x. So we're going to take this latter approach here and find the area using 2 times the integral from 0 to 1 of e to the negative x dx. Okay? So 2 times. Now keep in mind, we're still using our standard form because this is in the form of an exponential raised to a linear function here. So the coefficient of x here is -1. So using our result, 1 over -1 times our exponential between 0 and 1. Let's tidy this up. 1 divided by -1 is simply -1. So 2 times -e to the power of -x from 0 to 1, or 2 times -e to the power of -1 minus -e to the power of 0. So 2 times, in brackets here, we'll have -e to the power of -1, and this gives us double negative gives us a positive. So plus e to the power of 0, and hopefully we remember that anything raised to the power of 0 is simply 1. So this will give us a result of +1. Now we're talking about an area, so let's not forget our result is in terms of units squared. So we could expand this or leave it in factored form. If you were to expand it, this would simply look like -2 e to the -1 plus 2 units squared. And if you wanted to take it that step further and not have it written in negative index form, we could write that as -2 over e plus 2 units squared.